We're going to balance and determine which substance is oxidized and reduced. Or it says the first substance, but we'll do both. All right, for letter A, barium, let's write the equation. Barium metal is Ba, and put a S there in parentheses for indicate that that's in the solid phase, and that's going to react with oxygen gas. Oxygen is one of your diatomic elements, and we'll put a G there for the gas phase. Okay, this is two elemental forms before the reaction in the reactant, so they're going to combine. There's going to be a combination or synthesis reaction. So we're going to combine these two elements to form a compound. Barium oxide is an ionic compound, so we're going to use the ionic charges to get the formula unit. These twos are going to cancel out, and so this is going to be a 1-to-1 ratio. Recall, ionic compounds have high melting points, and so therefore that's going to be a solid. All right, to balance this, we have two oxygens on the reactant side, so we'll need a 2 at the coefficient of the products, and that's also going to unbalance the barium, so we'll rebalance it by putting a 2 there. Now we have the balance equation. Now we can work on identifying whether barium is being oxidized or reduced. Okay, so we'll just do this conceptually without using oxidation states. Barium has 2 valence electrons and oxygen has 6 valence electrons, and it's in group 16. And so what's going to happen is the 2 barium atoms are going to transfer their 2 valence electrons to the oxygen atoms, and that's going to make barium a 2 positive cation and oxygen a 2 negative anion, which is each to achieve the octet rule, and that's how they're going to be attracted in that ionic compound. Okay, so let me get some of this paint off the screen. Let me just write the charges here. All right, we don't write charges in the neutral compound, but the compound is made up of these charges. It's accurate to say that. Barium is losing electrons, as you can see, so the loss of electrons. You use the mnemonic Leo. The lion goes grr. The loss of electrons is oxidation. Barium is oxidized. You can see that oxygen is gaining those electrons, okay, to become 2 negative. So the gain of electrons is reduction. So oxygen is reduced. All right, let's move on to B. All right, copper 2 oxide reacts with hydrogen gas. All right, let's do that. All right, so that's copper. When it forms the cation, it's going to form the 2 positive cation, and oxygen again is going to form a 2 negative anion, and it's going to reduce to 1 and 1. So that's the formula unit for copper oxide. That's another solid, ionic solid, and that's going to react with hydrogen gas. Hydrogen is another diatomic element. All right, so put G there for gas. The products are given here to form copper, metal, and water. All right, form copper, metal, and then water is H2O. It's already balanced? Okay, nice. In this compound of copper oxide, copper has a 2 positive charge. Okay, and over here in the elemental form, all right, copper doesn't have a charge. So how do you go from a 2 positive charge to no charge? So it must have gained electrons to become this neutral charge because it has a 2 positive charge. Gaining electrons is reduced. So copper is reduced. All right, let's see what's going on with oxygen. Oxygen has a 2 negative charge in that compound, right? And then over here, it's also going to have a 2 negative charge. So it's not gaining or losing electrons. So let's go over to hydrogen. All right, hydrogen here is neutral on the. Got these colors flipped around. So there's no charge on that element. But over here in the water molecule, right, it's you could say it's acting as a cation, so it's going to be a 1 positive charge. All right, so how does a neutral atom become a 1 positive charge? Okay, it must have lost electron. So loss of electrons is oxidation. Loss of electron, oxidation. So hydrogen is being oxidized. All right, the combustion of ethene, C2H4, and combustion is going to require oxygen in the reactants, and complete combustion is going to produce water and carbon dioxide. Do we need to balance this? We do. Okay. There we go. We have it balanced. Let's figure out whether the carbon is being reduced or oxidized now. These are not ionic compounds, so we'll just you'll have to use the concept of whether it's partially losing or partially gaining electrons. All right. So carbon here is the CH bond here. Okay. The carbon, and the carbon is also connected to the other carbon, right? But let's just say, but in any case, the electronegativity is pretty similar. Okay. Compared to the carbon over here is connected to the oxygen. All right. So this is connected to carbon and another carbon, and let me see here. I don't have enough room to draw the whole molecule, but okay, let's just leave it like that. But this oxygen is much more electronegative than either the hydrogen or the carbon. So this is going to, the carbon is going to experience a partial loss of electrons. All right, so right now it's kind of sharing evenly because electronegativities are pretty similar, but oxygen is the second most electronegative element on the periodic table. So more of those electrons have shifted toward away from carbon. So you could say carbon is partially losing electrons. All right, and so recall, loss of electrons is oxidation. So you would say carbon is being oxidized here. All right, that's all I'm going to do for this one. Calcium oxide and aluminum metal. All right, calcium oxide, that's the formula unit. All right, 2 positive and 2 negative, they're going to crisscross and cancel out. Calcium oxide is going to react with aluminum metal to form aluminum oxide. You can tell from the Coulomb attractions there. What I mean by that is the very, the large charges here. All right, that's going to have a very high melting point. You can expect. Calcium, we got 1 on the reactant side. Oxygen, we have 1. Aluminum, we have 1. On the product side, in the same order, forgot the L. 1, 3, and 2. Aluminum's all by itself here, and so is calcium. I'll do those last. So I'm going to do oxygen first. Multiply the left side where you see oxygen by 3 to balance that out. It's right there. That's going to turn calcium into 3 as well. All right, so let's do calcium because it's all by itself. Put a 3 there. All right, now aluminum, let's put a 2 there. Looks good. Looks good to me. 3, 2, 1, 3. Let's just do the first substance because that's all the question is asking. Calcium here in this compound has a 2 positive charge. All right, and then after, we've seen this before. There is no charge on a neutral atom. What is going on with this calcium? To go from a 2 positive charge, it must have had 2 fewer electrons, right? To a neutral, so it must have gained electrons. So gaining electrons. All right, calcium is reduced. Okay, we're done.